Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable Series. This particular session of our Roundtable Series is focused on the Mork Family Department of Chemical Engineering and Materials Science, and we have a fantastic panel of faculty to not only tell you more about themselves, but also help you have a better understanding of chemical engineering and the various specializations and disciplines inside of chemical engineering and understand what the curriculum is all about. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the Viterbi School. I'll be your host for today. And here's how today's session is going to work. I'm going to lead the first half of the session, all about the discussion on the curriculum, and we'll talk about research. We'll learn a lot more about our faculty, and I'll guide that discussion as we go. In the second half of the session, or toward the latter half of the session, I'm going to ask you to ask questions. So think about your questions as we go through this first half, but please hold your questions for now. A lot of the stuff we're going to discuss might actually answer those questions, or they will provide some important context to help you ask some better questions down the road. But hold on to your questions for now. I will open up the Q&A feature as we get towards the latter half, and we'll make sure and have a really great conversation that will last for this whole hour. But without further ado, I want to make sure that we introduce our faculty. And so I'm going to have them introduce themselves, and we will start with the chair of the department, Dr. Hodge. Dr. Hodge?
Hello. So my name is Professor Andrea Hodge. I am the chair of the Mork Family Department. I'm actually a material scientist and I work with metals. I've been at USC for 14 years and I work with a lot of undergraduate students in my lab. In the past and currently, we have about 4 right now, and 2 of them are from chemical engineering. And I'm looking forward to telling you more about our department and all of the cool stuff we do.
Next up, I'd like to have Dr. Sharada introduce herself. Dr. Sharada?
Hi, everyone. I'm Shaama Sharada. I'm an assistant professor in chemical engineering. I teach the undergraduate elective on sustainable energy and the core class on separations. I love having undergraduates in my lab. We do a lot of computational chemistry and trying to simulate how electrons move in molecules. I look forward to interacting with all of you.
Thank you very much. And Dr. Zeno.
Hi, Hi, my name is Wade Zeno, and I'm an assistant professor here at the Mork Family Department of Chemical Engineering and Materials Sciences. Currently, I have 2 graduate students, and my research focuses basically on how the molecules inside of cells work and how cells carry out the functions that they do. I love working with undergraduates. I'm going to be teaching the undergraduate course in mass and heat transfer next semester in the spring.
All right, great. And I apologize if you heard my dog barking, but she's going a little nuts when the Amazon person shows up outside. And last but not least, currently a giant outside of HEDCO right now is Dr. Iraj Ershaghi. Dr. Ershaghi?
Okay, thank you very much. Hello, everybody. My name is Iraj Ershaghi. I'm a professor and a director of petroleum engineering within the Mork Family Department. My area of focus for years has been the digital transformation of oil and gas industry. And in recent years, I've been focusing more on energy storage and also use of renewable energy. And in fact, we are starting a new program in low carbon petroleum industry. So we welcome you to join our department. And I'll be very glad to work with many of you.
All right. Well, as I said, we're going to be taking the discussion in the beginning all about the curriculum and et cetera. And then we'll have you ask questions as an audience later on as we get to the session. What I did neglect to mention is that today's session is going to be all about the discipline and the classes and the research in chemical engineering and material science. If you have questions about admission or the application process, please, we're not asking those questions today. You can go to one of our admission information sessions. We hold those on Tuesdays and Thursdays. One of my colleagues, Rebecca Biter, is in the background. She will provide some information on how to register for one of those sessions inside of the chat. So my first question to all of you as faculty, it sure sounds like it's going to be a simple question, but I know it's probably one of the hardest questions we're going to ask. Maybe we'll have Dr. Hodge take the first pass at this, and then anyone else wants to jump in. What the heck is chemical engineering?
Okay. So at this point of the career, I think you've been in, you've taken a couple of chemistry classes and a couple of physics classes. So chemical engineering, as the name says, it has chemistry as well as engineering on it. So the difference between, I think, science and engineering is that engineering are in the apply realm of this. So if you have been heard about in the last 2 years about vaccines and things like that, and how to process vaccines and problems that plants making vaccines. And that's a lot of the things that chemical engineers do. They do the processes, not necessarily building the vaccine, although you could also do that, but all the processes that make, you know, how to configure different chemicals, how to configure different pharmaceuticals, how to configure all these yummy things that we eat. So it's the engineering applied part of chemistry. So I always think engineering is much more fun because everything is applied and you really get to impact the day-to-day life. So that is my kind of like general idea of what the chemical engineers do. So you use science and apply it to solve engineering problems. But again, I am a material scientist. So I think I will pass it over to my colleagues, such as Shaama and Wade, who actually have all the degrees in chemical engineering, and they have their own perspective. So Shaama and Wade?
I think Andrea mostly covered it, but I think increasingly now, because there are so many challenges that we are facing in terms of like an energy crisis and the fact that we need to reduce our dependence on fossil fuels and so on, I think chemical engineers have a critical role to play because a lot of energy consumption comes from the chemical industry. So it's going to be you guys who are going to figure out like, hey, how are we going to make these processes more energy efficient? How are we going to make sure that we have a sustainable future and so on? So Wade, do you have anything to add?
Not too much, but like I said, Andrea did an excellent job describing what we do. And, you know, to add in from my perspective a bit, like, you know, we're in the middle of a pandemic right now. So it's clear now as ever how important it is to be able to scale up these processes where, you know, we can mass produce vaccines and different things that are relevant to human health. So as Shaama said, it's going to be all of your jobs to help us figure out how to do that in the years to come.
Iraj, I know you have a unique perspective as the director of petroleum.
No, actually, chemical engineering has changed over the years. If you go back 50 years ago, it was nothing but refining. But now the chemical engineering graduates work for many, many industries, from aerospace to the software companies. They get involved in the pharmaceutical industry. They get involved in the food industry. So it's a very diversified field of engineering. In fact, among all of the engineering fields, this is the only field that will apply to many, many different industries.
I have a fun fact that I want to bring out because I'm in a committee for the National Academy of Engineering. And basically where I see the chemical engineers of the future fitting is if we ever going to have any successful space exploration missions, the chemical engineers here need to figure out how to make food over there. And that would be a chemical engineering job. And I think that would be pretty cool. I don't know if it would be, you know, interspatial chemical engineering or something like that. But I think it is highly dependent of this field to make that a success. So without food, there could be no people there. So, and without chemical engineers, there will be no food in space. So I think that's a challenge I'll give to all of you as a fun fact.
Very cool. I think that's a nice transition into, you know, we have a lot of, we have mostly high school students in the audience. There might be a few transfer students as well at other colleges, but the grand majority are in high school right now. They're in their senior year of high school and they're thinking about applying to USC and they have an interest possibly in chemical engineering. Can we describe, maybe first broadly, but then maybe we can also dive into specific courses. Can we describe the curriculum? What's the arc of the curriculum? How does the chemical engineering curriculum start? What types of classes do they take? What do they move through? And also, if you wouldn't mind, I'm making this a complicated question, of course. What is a college class like? I mean, you all are college professors. All they know is taking a high school chemistry class. What is a chemical engineering class like? What's it like taking classes from all of you? Sorry, that's a lot built into the question.
Well, I will start with the curriculum part, since that is kind of what some of the things that I take care of. So if you're starting in as a brand new freshman, you basically have some general education electives. You have your math and chemistry classes, the general chemistry classes and chemistry lab in your first year, a writing class, and again, kind of like your basic to give you the fundamentals in chemistry and physics and math and general education. And you really start getting more into the chemical engineering classes more into your second year. If you're a transfer student, obviously you start that right away. And you start with fun things like thermo and different labs, chemical engineering labs, about processes that we discuss, and and it keeps building up into more higher and higher level chemical engineering class. But in the first year, you will be with a lot of students in your cohort, which means in the same group as you, and that you will meet later in more and more of the classes as you get more specialized into in-depth chemical engineering classes. I only teach at the material science classes and some undergraduate mechanical classes, but I know that perhaps some of my other colleagues here can talk to you about what is a general chemical engineering class. Don't be shy.
So I think so at the end of 4 years, all of you will be doing like a design project where you will be designing a chemical plant from scratch. So all of the classes in your 4 years kind of lead up to that. So they're all interconnected in various ways, and you will see all these connections as you go along, at the end of which you will have the ability to essentially construct your own plant and make the chemical of your choice. So I think that's how the classes are constructed. And the idea is to give you a sense of how to model complex things. Like you have in a chemical plant, you have chemicals moving about, things being heated up, things being cooled down. There's mass transfer, momentum transfer, heat transfer, and so on. So you learn all of these concepts, you learn all of the mathematics behind them, and you will also learn to apply them to do something practical.
I think go ahead.
I used to teach the introduction to chemical engineering, and I was making it very clear to the student that really what distinguishes the chemical engineering versus chemistry is the economics. In other words, you can make an aspirin tablets that could cost $5 a piece. You can make one that would cost you 10 cents a piece or even less. The role of a chemical engineering is to design the system, manufacturing system, plant system that will produce a particular thing at the lowest possible cost. That's really what distinguishes the engineering in general, in particular chemical engineering. So you will have a heavy emphasis on how to design this thing that would be good for in terms of safety and economics. And that really distinguishes you above the science majors, the so-called physics or chemistry majors.
Well, I think it's about, human health and sustainability and environment. That's what it comes down to, and making those things viable options, not just for, the first tier countries, but for every country on Earth and outside Earth to be able to have those processes and access to these things. So it really is a life-saving, food creating technologies that you develop as a chemical engineer. And basically to apply to every part of human life is very much touched by what chemical engineers do.
I just realized I was muted. I wanted to, so basically the summary is that chemical engineers do everything, right?
Pretty much.
They make everything that wasn't already here before. And I like that answer because it's not, there isn't one industry that is a chemical engineering industry, and it's interwoven across a lot of areas. And I think that's important for our students to understand, in that it's like, well, do I want to go be a chemical engineer and work at a chemical engineering company? And that's not the case. It's how chemical engineering can be applied. So I really love how that was kind of woven in the end use applications, and how it's so critical, if you want to use a computer science term, in the stack of development of different types of products and different types of health and human services, all across the board, materials, et cetera. Now, there are specializations that students will see and emphases inside this, and that nanotechnology and biochemical engineering and sustainable energy and petroleum, et cetera. One thing I want to make sure I outline for everybody right now, you don't need to worry about this on the application. You don't even choose that on the application. It is part of your evolution through the curriculum. So don't feel like you have any pressure on this, but I know a question we always get, and so I'm going to cut it off at the pass, is, well, which one's the best one? Where do I have my best options? And I know Iraj's answer, but I want to make sure, we talk about, like, what are the differences? Do you get pigeonholed in one versus the other? Are your options limited or changed because you have one degree over the other?
I think actually I should mention that we have changed the curriculum. So for these incoming students, it will be even easier because we are putting it into just 3 categories.
Right.
And so energy and sustainability, materials, and pharmaceutical engineering. So it would be much easier to pick, but you don't have to pick anything. You can go general and you can say, well, I want to take 1 class in sustainability, 1 class in materials, 1 class in pharmaceutical engineering, or you can make it more of a cohort. It's up to you, because we also have our general just chemical engineering degree. It really doesn't matter. It's just the electives, and you can pick any electives you want, or you can go and focus the electives. But we have heard the students and we have made it easier. So starting next year, it will be a lot easier to pick. So you don't have, so it's less confusing, and it also gives you more options to pick and focus on different things. And yes, go ahead.
Oh, no, I'm sorry. I love these 3 options. This is great news for everybody. Can we describe the differences between them? I mean, they're a little self-explanatory, but what would someone take in pharmaceutical versus sustainability and I think I heard them right, energy and materials?
No, sustainability, energy and sustainability. So energy and sustainability would be anything from solar panels to petroleum, anything that drives energy, and how that functions with sustainability. So you can take a class in green energy. You can take a class on just understanding how energy works and how we can make the current structures more efficient. If you go into materials, then that's going to have some of your nano emphasis. It could be, again, photonics. So that means like optics, solar cells. It can be just making materials. It can be looking at making polymers, making new plastics, right? Greener plastics. So they kind of intertwine. And again, in pharmaceutical engineering, then there will be more of like the bioengineering classes, tissue engineering, most of those things that talk more about the interaction with these pharmaceutical processes that we just talked about. So because it is up to the chemical engineers to keep the world healthy and to make sure everyone can get access to medicine, so that will be some of the stuff that will be covered under that.
Great. Thank you very much.
I should mention that, just one clarification. USC's chemical engineering is accredited by AVID. Now, what that means is that there are a certain number of courses that to be an accredited program, you must take. But beyond that is all elective. So students have a wide choice in terms of what courses they take. But if they want to specialize as an option in these 3 areas Dr. Hodge indicated, then there are specific courses they can take. But the core courses that are part of the accreditation is the same for everybody.
Right. That was fantastic. I'd like to switch gears a little bit here. And given that we've talked about these specializations, it starts to lead down this path of research. And there's a phenomenal amount of research going on inside of the department, and they tend to overlap with a lot of these topics we just discussed. So can we give an overview of the types of research that's happening in the department? And maybe you all can jump in with your own individual projects and help explain what you're currently working on.
So maybe I'll give a chance to one of our assistant professors. Wade, would you like to come in and talk a little bit more in the bio side of the department?
Yeah, sure. So some of the work I'm working on has very tangible applications is trying to deliver trying to develop new technology for delivering drugs inside of the cell. So that's a huge barrier in terms of like drug delivery and developing therapeutics, because cells just don't let anything inside of them. You have to kind of trick the cell and exploit some of its natural processes to get things inside. So that's why we study how cells work. So then once we get a good understanding, we can now engineer these different nanotechnologies that let us trick the cell to letting us inside, kind of like a Trojan horse. You can think of that analogy. So I'm getting a lot of that work up and running, as well as some other type of fundamental work with looking at cells, and then maybe down the road, figure out how we can scale these up for mass production if it ever gets to that point.
I should mention that after the second year, after sophomore year is over, and I mean, most of the students actually get a summer job. And from the summer job, when they come back, many of them have shown interest to actually do something in that area. So at least I've been supervising undergraduates who are actually inspired by the work they did in the summer, and they want to do something in that area related to the energy. So in many cases, we've had very successful actually publications coming out of this work. because of the fact that the original inspiration came from a summer work. And so sometimes that's the reason. And sometimes basically, of course, you end up working with a professor in their lab on something new, and then you take that to the field. So it could be either way.
Shaama, you want to talk a little bit about what you're doing?
Sure. So my group does not do wet lab work. All our experiments are on computers. So we use the supercomputing facility either provided by USC or by the National Science Foundation. One of the problems that we're looking at is climate change is driven primarily by increasing carbon dioxide levels, right? So is there something we could do with the carbon dioxide? Can we find ways or can we find reactions that will convert carbon dioxide back into fuels and therefore have like a carbon neutral cycle? So we are trying to design those reactions in my lab. I have about 6 undergraduates in my lab, and in one way or another, they managed to find nice sources of support from USC. So USC has the Provost Research Fellowship, which is purely for undergrads. I was also able to secure funding from the Undergraduate Research Associates Program that is also purely to support undergraduate research. So if you want to do research, you can find a way to get paid for it here at USC. So there are all sorts of incentives to encourage you to do research when you're here.
So although I'm not a chemical engineer, but I do use lots of chemical processes in my work. I'm a metallurgist, so I develop metals and materials. So we have a lot of students in chemical engineering that are interested in materials in general. I mean, you use some materials for almost anything as well. And so we look at things such as things for energy and climate research. So optimizing materials. So I'm interested in extreme conditions, corrosion, very hot, very cold. A lot of my students are involved in NASA projects. And so we really, hopefully together, we'll get those people to Mars, not me though, I'm not volunteering, but we will get the things to get people there so that materials that they need, mostly in metals and ceramics that we're working on, but we also have other people in the department working on polymers as well. So kind of materials that will sustain extreme environments and still be viable for very different environments, whether it's here on Earth or in another planet.
Very cool. Let's talk a little bit about outcomes. Undergraduates go through our program every 4 years, they graduate and they go somewhere else. The grand majority are going straight into industry statistically, and then some are going to grad school as well. But we know over time that alumni go to grad school because industry pays for it as well. But can we just anecdotally, where have chemical engineering graduates gone on to? Where do they end up working? Or if they go to grad school, where do they go to grad school?
Well, I mean, we did a really nice collage this last graduation cycle because it was still partially online. And I would say they went everywhere, actually. We had people in SpaceX to people in the refinery. So it seemed to go, I can't think of a single, two of them going to the same place. They seem to have gone in many different places, but I think the main thing was that they were doing things that they were very interested in, whether it was fuel studies to chemical corrosion studies to pharmaceuticals. I think that it was really to Mork. So it's very different types of industries that they all went to. In general, some of the students that have worked for me in the past, just as an anecdote, they have gone mostly to graduate school. So I do have a student that finished already in the MD PhD program at Harvard, MIT. So it just depends what the student wants to do and what they're interested in. So they came into the group saying that they wanted to go to graduate school, and that's what they did. But a lot of our undergraduates go and get jobs that they're interested in, and they spark their interest.
Just as a reminder to our guests, please hold your questions for the time being. I'm going to open up the Q&A in just a minute or two here, so just sit tight for right now. What I would really like, I want to go back on curriculum because I realized I didn't ask one specific question, which is this concept of theoretical work or theoretical coursework versus hands-on coursework. Can we talk about the differences and maybe give some examples of what types of, what is theory work, what is hands-on work, and how students will find balance in their curriculum?
Wow, I'm looking at the curriculum right now, and I can see, for example, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 labs or so that they will take. That's all Handson. That is usually something the students really love to their curriculum, and they get to do things such as, change pH of different liquids, to measuring different pressures. I think some of those labs are computer driven to design different processes as well. And I think the other faculty here who has taught those classes can speak a little more, but quite a bit hands-on. So there's the basic fundamentals that tells you how things work, and then the hands-on projects that show you how to work and let you make mistakes and make you learn from, so you can apply what you learn in class. So I know Shaama and Wade's coming up with a class here, and I know Shaama and Iraj had that quite a bit. So maybe they can speak more about it.
Yeah, I'd like to actually talk about a particular thing that maybe we didn't discuss, and that is some of the students will come as an undergraduate. They bring some of the advanced placement courses that they've taken in high school. And as a result, they can theoretically graduate in about 3.5 years. And of course, if they maintain a good GPA, they actually apply to a PDP. It's a very interesting program because that allows them to stay 1 more year and actually earn a master's degree, which of course gives them, a much higher capabilities in terms of employments and the choices they will have. And I have actually seen in many cases people get into the PDP while they have a job. And so the company is actually supporting their master's degree and they're doing their PDP. So I'm very encouraged that actually they're having the PDP option is really opening up some new opportunities for the undergraduates who are really looking beyond the undergraduate. The truth of the matter is that the subject matters have expanded so much that you cannot include everything in undergraduate. So you almost have no choices. If you want to specialize in any of these areas with a little bit more expertise, you almost have to get a master's degree. And so that option is available. I just want to make sure that we bring up this issue. Shaama, go ahead.
Right. I'm sorry, does anyone else want to jump in?
Like I wanted Shaama to maybe talk about her undergraduate class, maybe.
Yeah, so I teach the undergraduate class on separations. Essentially, the idea is like if you're making chemicals or pharmaceuticals, you're making a mixture of things, right? And you have to separate your medicine from all of these other side products. So how do you go about doing that? And in my class, for example, we go through what the processes are, how to design these processes and so on. And then you go into a lab class and you actually you actually see that in practice and you get to try things out on your own. So both theory and hands-on experience go hand in hand in the department. That's all I had to say.
Thank you very much. And so I want to give our guests an opportunity to start asking questions. Feel free to start throwing in those questions into the Q&A feature. Here's what's going to happen. I'm going to ask our faculty one more question. And while we're doing that, you can type into your questions and upvote. So there is that thumbs up button on each one of those questions. When you see the upvote button, hit it if you like a question. We're going to go down the most popular questions first. So you decide what we're going to be chatting about. My last question to our faculty before we hand it over to the audience for the Q&A is there are lots of options for students coming out of going into college and figuring out what they want to major in when it comes to engineering. There's lots of disciplines inside of engineering, and every discipline is important into solving real world kind of global problems for people. So I'm giving your chance right here. Why is chemical engineering the best option for them? And trust me, I won't tell any other faculty from the other departments what you say.
Well, I think I'll get started. And I think as a material scientist that has learned to appreciate the field, I really think that if we're going to solve environmental issues and we're going to solve hunger issues as well as human health, it's all down to the core of chemical engineering. So if you want to solve people problems and immediate people problems and future people problems, I think chemical engineer is the core fundamental discipline that will allow this to happen, whether you want to go to space or just make sure everyone here has access to medicine. And I think that really speaks to this current generation and trying to make things right and trying to make sure that everyone has access and that everyone can have access to medicine and clean water and good food. Is all down to how chemical engineers figure out how to do this.
Yeah, the field is just so diverse. There's just so many different options to choose for a career path after completing a program here. So, you know, you're not just pigeonholed to one type of career or company you have to work for. You just, as Andrea mentioned, you just have all these different options.
There was a question here that as a transfer student, what are the options? Yes, we do get a lot of transfer students, but one thing you have to realize is that USC being a private school, you actually have the opportunity to spend a lot more time with the faculty. And I personally have, after being at the USC for many years, I suggest highly that you actually select a mentor to work with you all along the way. Not only is it going to help you for the summer placement, but also for full-time employment and research ideas. So I think having a mentor would be very helpful to you when you get to the undergraduate program.
Absolutely. So Iraj, don't break the rules here. I'm going to go through the upvoted questions first. So I'll handle the Q&A. Come on, man. Well, yeah. It's been a while since we've seen each other, but come on.
Okay.
All right. I was giving you a hard time, Raj. So upvote your questions and we will make sure that we get to the questions working our way down, and we have plenty of time for questions. So let's get them thrown in there and I will go through there. Eugene asked this first questions. Are there internal grant or fellowship opportunities at USC that students can apply for undergraduate research projects? Yes. So there's a couple things that you should know. Number one is that when you apply, you're automatically considered for a limited amount of merit research scholarships to be research fellows at the Viterbi School as an undergraduate. I mean, you come in with funding and you can actually take that to your faculty and get paid to do the research because we pay you as a school. In addition to that, as an ongoing student, there are other opportunities to apply for as a continuing student. Our brand new Center for Undergraduate Research at Viterbi Engineering called CURVE is an opportunity where students can actually get that funding and get paid to work with faculty and do that research, but also just working with faculty. Sometimes these faculty may have funding available for you as well down the road. And you don't have to be part of a formal program. As Dr. Ershaghi was just mentioning, regardless of your status of when you start, incoming first-year student, incoming transfer student, you don't have different opportunities. You have the opportunity to do research because these faculty are doing that research and you want to get engaged. So Dr. Ershaghi's message just before was great, is that you connect with faculty, you're part of the academic community, and your opportunities to engage in that research are just the same, regardless of how you come in. And we have some funding opportunities to make it a little bit sweeter on top. Dr. Hodge, did you want to say anything else onto that?
Nope. Okay. I think that you cover that well. I think faculty will also have their own resources. So just make sure that you reach out and we can work with you. Even that the department chair can work with you and try to find a good place for you to be. If you're not really sure where to go or how to fund it, we will find a way to make it work if that's what you want to do.
Absolutely. And we should talk about directed research courses too. There's opportunities to do research and get course credit for it as part of your opportunity. So basically, at a research institution with the volume of research being conducted at the Viterbi School, your opportunities as an undergraduate are incredibly flush. And that just means once you're here, it's starting to engage. So there are lots of opportunities. Jeremy asked this questions. Are there co-op and internship options for chemical engineers at USC? Absolutely, yes. I want to let my faculty jump in just a moment here, but I think we kind of skipped this a little bit, and that's my fault. When we talk about outcomes where students go, those are the same companies that are hiring you for co-ops and internships in your undergraduate years. Dr. Ershaghi mentioned students go off to get summer jobs. I've neglected to jump back in. He's talking about internships and co-ops. He's talking about working at these companies full time. And those are those internships, hundreds and hundreds of companies recruiting our Viterbi students because we have our own Viterbi Career Services staff that work with these companies to bring them onto campus to engage with you and to recruit from you. And we have a long history of helping these students get engaged with those opportunities during their undergrads, because that's how you get the experiences to then lead on to your full-time position after graduation. So anyone else want to jump in, or any other thoughts and comments on co-ops and internships?
Yes, I'd like to offer an opinion here. It's very important. You know, companies are not just necessarily looking for a 4.0 student. They're looking at a lot more. And part of that is getting involved in a student professional organization, such as SB, AICSU, whatever. And we always encourage you to do that. And through that, you develop the networking opportunity of dealing with the industry. And before you know it, you have your place with the company because they know you. So we always encourage that besides your academic work, you actually get involved in this kind of a student organization, develop your leadership capabilities, and do the networking. And this is something we highly encourage, and it's very beneficial to the students.
Absolutely. And just to add some clarification there, and I'm guilty of this as well. We use a lot of acronyms at the Viterbi School. So AICHE or AICHE is the American Institute of Chemical Engineers. It's a student organization, also professional opportunities inside of that. SPE is the Society of Petroleum Engineers. There's also a number of different design competitions like the Chemical Engineering Car and other design teams that maybe aren't, maybe purely chemical engineering, but people like to get involved in, like Rocket Lab or getting involved in the electric car team. All of these different opportunities are opportunities where you build that network. And so your engagement on campus starts to build into that network for your future opportunities. So don't pass those by. It's not like you just apply for jobs and get them. You build community, you build network, you then move on to that. So thank you, Dr. Ershaghi. That's a great point. Michael asked the question, what do you think are the main benefits of the recent change in the curriculum and addition of more specified areas of study? Michael, that's a great question, but I think I want to clarify, though, the change in curriculum is a streamlining. I don't think it's an addition of more areas of specified study. So I want to clarify that. There used to be, I think, like 8. And so we got it down to 3, which is actually better, in my opinion. But Dr. Hodge?
Yeah, no, so there were 7 and now there's
7.
3. And so the classes is still there. So you can still pick and choose. It just make it easier so you don't have to feel in a more narrow area, but broader, and gives you more options to take more elective classes in between that specific emphasis. So we kind of just put them together in a place that makes sense for them to be together, like energy and sustainability, the relatable things, right? Pharmaceutical engineer. We went from the topics and what the students were doing. So in the bioengineering classes, the biomaterials classes, pharmaceutical classes, we kind of group things together in a way that makes sense. But now you have more chances to pick and choose. But keep in mind that you can just use the general degree and just take whatever electives you want. So it really, you don't have to have an emphasis at all. So it just, we did not take away any classes. They're still there. They just electives. We just make it more flexible to you to pick and choose electives as you want.
So we don't pigeonhole anybody, and that gives more opportunities. And I think it was interesting, and Dr. Ershaghi, you and I have had this conversation a few times, and I'm going to put you on the spot, but it was this idea of incoming classes and younger students always focused on this idea of sustainability or sustainable energy, and then never wanting to take petroleum engineering classes. And you're like, no, this is all part of the same thing. Can you talk about how petroleum engineering is still a relevant area and part of the study of sustainable energy?
Well, it depends how you define sustainability. If sustainability is that sustaining civilization, we're going to need energy. We need food and energy. These two are very, and of course, shelter. So all of the forecasts are there that, we're going to have a change in the scenery. We're going to have more renewables, but the progress toward those is not as fast as we expected. Or we expect to be. So what happened is that at least for the foreseeable future, maybe in the next 50, 60 years, the hydrocarbons will play a very important role in the energy basket that we're considering. And remember, we may change the use of the hydrocarbons, but remember, most of the materials, the plastics, and all of that all comes from petroleum. So if you look at what the hydrocarbon will do for you, it's just a matter of realizing what an effect it have on our civilization. All we are teaching, all we're doing right now, how can you produce the hydrocarbon? How could you manufacture these products, making sure that you have the least harm to the environment? So it is really in the context of our curriculum to make sure we are producing technologies who can actually address this issue. How can you have a low carbon industry? And that's really where the focus is.
Thank you for that. This is the next question from Ayat, general question, but perhaps it's different for the School of Engineering, but what is the class size? I can give you a little bit of stats related to that, and then maybe you all can talk about your specific classes, but average class size at USC is 26, but individual classes vary. And I think that that's important to understand, and smaller classes persist. Sometimes what you should know is that the incoming first year class for chemical engineering is roughly somewhere between 25 and 30 students every single year. And so it's already a small department, and the opportunities to then keep splitting up as you go gives you small opportunities. But you all want to share class sizes that you have just off the top of your head?
Well, I mean, in the general classes for chemistry and physics, and stuff, those are larger because those are requirements. all across engineering and the sciences. So those tend to be larger. In our department, it depends. So in the general classes, they're usually 30 or so to 40 students. And then the ones that are elective classes, there can be 12 to 20 students or so. So it just kind of depends on the electives. And then the core classes, so the ones that everyone has to take, is something in the order of 30 to 35 or so.
Great. Rohan is asking a question because he's interested in material science, and he understands that material science is not his own academic department. And why are you hitting him like that? Why don't you have your own material science department? Why is it part of chemical engineering? Because other universities do that.
So as a material scientist, so my undergraduate anyway is in mechanical engineering. So the way I understood it and the way I still understood it, material science is a specialization. So you can have any degree and come and do material science as a graduate degree, but you can get some classes in material science as an undergrad. A lot of schools, not a lot of schools, but many schools do have undergraduate programs, but they tend to be pretty small. So most of the schools have something 10 to 20 students, sometimes even less. And they're mostly graduate departments because it's a specialization for physicists, chemists, mechanical engineers, chemical engineers, whatever, all sorts of different engineers. So I don't think that's that uncommon. Many universities don't have undergraduate material science, but you do get the course. So thermal is the same. So entropy and enthalpy, if you have taken that, thermal, well, not really, you shouldn't have taken that as an undergrad, as a high school student. But anyway, but there's things, those things don't change. And then you can take your electives in materials. And so you have a good and a strong materials background if you want to do that as a graduate student later on. But you still will get all the emphasis and all the classes in the electives that you would like if you want to do an emphasis in material science, because the core is not that different between both of them. There's a lot of overlap between chemical engineering and material science core. And then this way you get a larger cohort and exposed to a variety of things that gives you options open for things later on.
One of our faculty members, she is a material scientist, and of course I'm blanking on her name. God, who am I talking about? Me? She did her undergrad at USC.
Her undergraduate at USC?
She did undergrad at USC. She teaches material science.
But Lessa?
Thank you, Lessa.
Grunenfeldman. Oh, okay.
Boom. Yes, thank you, Lessa Grunenfeldman. Anyways, I had her on our admission podcast, and she's a material scientist, and we talk a lot about how, for lack of a better term, material science is the advanced discipline of whatever it is you're studying the first time. And it's not so much that you want to, in her opinion, you don't want to study material science as an undergrad. You want to study where you're going to apply material science to. So this idea of starting mechanical and then going material science, going chemical, going material science, because it's basically learning to walk before then you learn how to run, and then kind of apply that down the road. I don't know if that's a fair representation, but that's my brief summary. She did a much better explanation on our podcast.
Well, yeah, I mean, I was always interested in materials, but it was more like in taking my class, and I'm like, oh, everything needs a material. Okay, then I'll do that for grad school. It was sort of that thing, but I needed the background. The background is what gets you through it. So yeah, that's kind of how that works.
Yeah. So. Let's get to Catherine's questions here. You talked about integrating some labs that have to do with computer-driven design. So my question would be, how much technology and how large of a scale is technology used within chemical engineering? Technology is everywhere. I don't really understand this question. You want to give it a shot?
I can pretend I understand. So let me see. So if it's talking about computer-driven classes, then we have a large variety of electives as well as between the class, such as controls and things like that are computer-driven. And so the students get both theoretical and hands-on experience in things like, I don't know, you're talking about machine learning or something like that, but you can be exposed and take those classes. But as far as the technology, all the equipment in the labs is the latest technology. Everything, part of being AVID accredited is that we have gone through a rigorous process to make sure that you're learning current technology, not technology from 20 years ago, 10 years ago. So all the equipment gets upgraded in a regular basis, almost every couple of years. So you know that the equipment that you're using for your labs is the equipment that they have in industry. So whatever it is, the spectrometer to measure whatever, all the power generating or, measurement devices, all those are the latest pieces of equipment that's what industry will use or that what you will use in graduate school. So if that's kind of what the question is, then that's part of the AVID accreditation, and that gets done in a very regular basis to make sure you use the equipment that is used today.
I think what I might jump in on here is that I think that okay, good. Catherine's saying yes, that's the question. This might be that something that we talk about specifically. It comes up with chemical engineering. Sometimes it comes up with civil engineering. In that kind of the younger generation comes in and says that like, oh, all the cool new stuff is computer science and AI and all this other stuff. So like, do you guys do new stuff? And I think that's not necessarily what Catherine's asking, but I think that might be this like shadow of people thinking that chemical or civil is like old technology, and there's no such thing about old technology necessarily.
Well, I think the problems are new problems, right? Yeah. With like I said, we were talking about explosion of just people, the number of people on Earth, going outer space. Those are new problems that didn't face before. So the field evolves for the new challenges, and therefore that's how the new technologies are implemented. So whether you want to do chemical engineering and do machine learning and AI, that is completely something that we do now that maybe wasn't done 10, 15 years ago, but now it's part of this because you're solving larger scale problems. So the field evolves as the technology evolves and the problems evolve as well. So why would you care about Mars, 85 years ago going to Mars? It wasn't as feasible as it is now. So now the problems are different and what you had to face is different and the solutions are different and the technologies available have evolved. We have computers, so that is integrated into the curriculum, integrated into everything we do, software, writing languages, Python, things like that, that you need to know in order to be the best engineer that you can do, and then you can get the kind of job that you want to do after you finish your degree. Does that make sense?
Yes.
It's not
Dr. Ershaghi, it looked like you were going to say something.
Yeah. So you need to know that after you actually get a job, you're going to do everything with the software. Most likely they're not going to ask you to sit down and write the software. And so the software companies who actually manufacture these design and software packages, they have incentive to make sure that you use their software. So that's why they make multi-million-dollar donation to the campuses. I know in the petroleum part, we have $200 million from Halliburton, $50 million from Schlumberger. And there's a reason for that. Because when our students play with these software packages, when they get a job, guess what? They're going to recommend those software packages. So you are going to be exposed to the up to the par software packages that are used in the actual workplace. And there's nothing to worry about that. That is part of the system.
All right. Well, it looks like we did a great job. We went through all of the questions. I want to give a couple final notes here, but I do want you all to have the final word before we sign out. So I'm going to give you a couple minutes to anything you want to say before we close out. But for all of our students joining us, thank you so much for being here. I truly appreciate it. We have lots more information on our website, other faculty roundtable sessions that have been recorded in the last couple of weeks. We have 2 more that I think are coming up this next week. If you'd like to learn more, the application process is live right now. Go to commonapp.org or go to admission.usc.edu/Common App to start your Common App and make sure you get that in by December 1st. We're coming up rapidly, about 6 weeks away from the actual first year application deadline. And for transfer students, that's February 15th. So you've got plenty of time. You can relax a little bit. If you ever need anything from us, you can always reach out via admit@usc.edu. Give us a call at 213-600-9919, or you could text us that number as well. And we have other admission information sessions that Rebecca put into the chat. So if you'd like to join us at that, we could talk more specifically about the admission process, specifically for first-year students, specifically for transfer students, and the details that ride therein. There's so much stuff happening, and we also have a big on-campus event. If you are in the LA, Southern California region, you can please come to us. Come check us out November 6th. Saturday, November 6th, it's our triumphant return back to campus for an on-campus event. It should be fun. It should be exciting, and we'll be there to answer your questions. So final last words from our faculty. Who would like to say anything to our guests?
We start with Wade because it starts with a W.
Yeah, Wade.
So I'm the newest faculty here, and so far it's been an amazing experience here at USC. I'm definitely enjoying this department in comparison to the other chemical engineering departments I've experienced in my long track of my academic endeavors. And I really hope that all of you consider this as a place to pursue your undergrad degree. Southern California is a really amazing place to be.
Thank you, Dr. Zeno.
I should say that if you're not familiar with the website of the department, it's chems.usc.edu. I encourage you to actually go to the website, see the faculty profile, and if there's a particular question you have, you can just email that faculty. And I think that kind of a communication should be going on before you even apply to USC.
Shaama?
Yeah, just one final thought. Paul already mentioned about student associations, right? So student associations in the department are extremely active. They have like year-round activities that either within the campus or through local chapters. I just wanted to add that there is a new student association that I am the faculty advisor for, and it's the Women in Chemical Engineering. It's not specifically for women, it's for all students in the department, either graduate or undergraduate. And the goal is to make sure that we have a strong mentoring network in the department. So we have industry panels, we have podcasts, we have webinars, we have like trivia events. So there's a bunch of things going on around campus. So check that out as well. Thank you.
Very cool. Thank you.
Well, I hope, as the chair, to see you here next year. I think I'll give you some more fun facts about chemical engineers. They seem to rule everything. So our provost is a chemical engineer, or dean is a chemical engineer. UCLA's provost is a chemical engineer. UCLA's vice provost is a chemical engineer. So you see the pattern there? So maybe there's something in here in the water that you make or you measure the pH on that changes everything. But it's very interesting to see the people that actually is not just leading science, but also leading the fields and leading academic universities. So I think you will enjoy it. It's a fun department. I got to know the students quite a bit over Zoom this last year or so. And they all said, my best friend is in this department. We spend so much time together. They love the experiences. I think besides the academic strengths that they all have, how much they love and they appreciated their cohort and how well supported their cohort was to them in a big part of their lives. And every single student that we interview, every single student who talked to us said, my best friend is from this department. And so I think that says a lot in a world that we all need to connect in a department where we solve human problems, human health, human food, human issues. Everybody feels better because of chemical engineering. I think it's very important the fact that you have also that human connection in that same department because of the size of the school, the size of the department and the size of the cohort. So hope to see you here next year. We have great parties. So that's another thing, like ice cream parties. That's what I mean. We're engineers. And I hope to see you here next year and looking forward. If you have any question as a department chair, I can connect you. So looking forward to seeing you here.
Put it on record. Come to chemical engineering. We got great parties. Like that. That's it. That's going to be the brochure from here on out. I love it.
I said ice cream party.
I know I did. Dr. Zeno, Dr. Ershaghi, Dr. Sharada, Dr. Hodge, thank you so much for spending time with our prospective students. I really appreciate it. For all of our guests, thank you. The recording will be up on our website just in a few minutes. Have a great evening, everybody, and a great weekend.
Thank you.
Take
Bye.
care.
Bye. Thank you. Bye.